Thanks very much. We've dimmed the lights, especially so you can all have a snooze just after lunch. It's a nice siesta time. Yes, my name's Andy Allan. For those of you who don't know me, I'm a freelance digital cartographer, and I've been working on OpenStreetMap cartography since 2007. I created the open cycle map layer and the transport layer that you see on OpenStreetMap.org, and I also am the maintainer of the main map style. Most of my business, both as a freelancer and other projects, are based on OpenStreetMap data. And my most recent project has been involving vector tiles, which is what I'm here to talk to you about today. Just over a month ago, I pushed the big red button, or rather pushed a commit to a repository, in order to change the transport layer that you see on OpenStreetMap from using mod-tile to using my new vector tile setup. It was late on a Monday afternoon. It was supposed to be Monday morning, but there was a few last-minute hitches, and so I pushed it, went straight to the pub, and forgot to write any blog posts or anything about it. So this is the first announcement that this has been happening. This talk will be discussing the road to vector tiles, although I have to say it's neither as smooth, as fast, or as well lit as this picture suggests. I would say it's more like this. So let's talk about some background in order to put the vector tiles into context. Most OpenStreetMap layers that you see online are produced by a piece of software called mod-tile, which was mentioned in an earlier session. It's a module for the Apache 2 web server that takes inbound requests at the top, checks whether or not there are pre-created map images in the disk store, and if so, serves them immediately. Or if not, communicates with render-d or Tyrex daemons. These are programs that run continuously on the server in order to create the map images. They can deal with PostGIS databases, with shapefiles, with TIFF files, or any other data source, and create the map images. When render-d has created a map image, it's important to note that it gets stored into the disk store, and then mod-tile is available to serve it from disk. There's a subtle thing that some technical people will appreciate, the difference between a disk cache and a disk store. For this system to work, the disk store has to be there. It can't, if it's full, then you can't create new images. If it's missing, the images can't be served. It's not a cache, it's a store. Now this is a very well known, very well tested, very well used piece of software. It's what I've been using for years as well. And it's a great system. It's fairly straightforward. It works, it's very, very reliable. It can serve hundreds of map tiles per second for months on end without any problems. It reads mapnik style sheets, standard format mapnik style sheets. So these style sheets work with other pieces of software like Nick to image or map proxy or anything else that consumes a mapnik style sheet. We're not just tied to spherical Mercator projections. We can use esoteric projections reasonably easy, again with the same style sheets. And the overall data process is quite straightforward. You pull the data from the database, you create your map images from it, there and then. It's a very simple, straightforward setup. And it works great when you're running one map style. You only have one big set of images that you want to create. And when you're running on one server, it's great. So it's by far the easiest way to get started at serving any kind of global map using OpenStreetMap data. But as time has gone on, and I've been expanding my use of mod-tile and moving into larger numbers of maps and larger rates of map traffic, there are certain limitations about this approach that come in. The biggest one is you end up with lots of raster images on disk. They have to go onto disk. They can't just be channeled on the fly. You end up with terabytes of map images. This is great when people want to view a map image that's there already, but there's lots of processing to get there. Updating them takes a long time, and also just dealing with how many servers you need in order to have enough disks. Every style sheet that you have needs its own disk store. even if it's only one tiny little change. If you have a terabyte of map tiles, you now need 2 terabytes of map tiles, 1 for each style. They all take up space. It's also tricky to scale them horizontally because every server ends up with duplicate copies of the same map images and they take up space. And one of the final bit here is about user requests triggering database calls. It's one principle of architecture. I'm not saying it applies everywhere, but it's nice if you can isolate your database from your user traffic. That means if you have surges of traffic, it doesn't increase the number of requests to what is usually the most expensive disks and most expensive software that you're running. In terms of resources, I mean, not in cost. So vector tiles are an alternative approach to doing this. I'm not going to say they're a better approach, they're an alternative approach, but I like them. I've spent months working on this. I think they're the best thing since sliced bread. But apart from that, just definitely an alternative. For a great introduction as to the technology behind these vector tiles is to see the videos that Dane Springmeyer has made at the last 2 State of the Map conferences. They're both online. His one from 2013 is especially good at explaining all the technicalities of it. And I'm not going to repeat that here because many of you have seen this before. But in essence, a vector tile is a way of taking OpenStreetMap data, packaging just the data that you need for that one map image, and then saving that data to disk, already pre-prepared, ready to color in and create a map image from. It allows us to mess around with the architecture of how we want to create these map images, and also has a few side benefits that aren't immediately obvious. One of them is that a vector tile at zoom level 14, it's completely easy to put in all the data that you need for zoom levels 15, 16, 17, 18, 19, 20, 21, all of that into one zoom level 14 vector tile, which means all of a sudden we're dealing with reasonable numbers. We're dealing with hundreds of millions of vector tiles to cover the whole world instead of billions or trillions of map images. And so again, we have an amount of flexibility that we can do cool new things with. Dane always uses the example of ravioli, which is why I'm doing the same thing. Each parcel contains all the data, and also just this little bit around the outside that's not in the tile, but is enough to prevent getting edge artifacts when you try drawing them at the end. So they all overlap very slightly. The first piece of software that you'll encounter these with is called TileMill2. I've got a number of previous talks discussing TileMill1. TileMill2 is not the successor to TileMill1. It's a new project. It only works with vector tiles, but it's a great place to get started. It looks very similar to TileMill1. If any of you have used it before, you can write your style sheets on the right-hand side, see the live updating map on the left-hand side. But behind the scenes, this is all based on vector tiles. By default, downloading them from a Mapbox collection of vector tiles, but we can change that. One of the features in TileMill2 or one of the new features, it's only a month or 2 old, is the ability to turn on a kind of X-ray vision and see what's in the vector tiles themselves. One of the big disadvantages of vector tiles is that you can't see them, and often it's kind of hard to know what you've put in them. Did you include extra things by mistake? This X-ray view is very useful for figuring out what features are in there. You can also click on features and see what attributes they have, which is something I've always wanted in TileMill1. It's great to see it in TileMill2. You can also use TileMill2 to create vector layers, but this is very rudimentary. Again, it's very new. All of the vector work that I've done has been creating the control files for the vector layers by hand, basically back to the bad old days of writing XML by hand. So I've only played around with this very briefly. It seems to work, but bear in mind that it's not 100% featureful. It does let you, however, play with vector tiles based on your own data, not necessarily other people's data. So you can load up shapefiles, you can connect to a local PostGIS database, use it to create some vector tiles, and style them in tile-mill too. So it's worth knowing that it's there, and it's worth using it. Apologies that the screen is a bit washed out and you can't really see these dark tiles. Both tile-mill 2 and everything else surrounding vector tiles is written in a language called Node.js, which is the bane of my life, and I hate it with a passion. Writing in Node.js is just overcomplicated for no real good reasons. You end up writing callbacks for everything, regardless of whether you want to wait for callbacks to happen. And if it wasn't for all the other advantages that vector tiles bring, I wouldn't touch it. One of my particular hates with Node.js is the packaging system that they use for it, called the Node Package Manager. People like writing Node.js modules and use this package manager to distribute them, but they like writing modules for everything. So this is the dependency graph for turning a vector tile into a map image. And this is how many modules are involved in that. One of them in the middle, and I know you can't read it, is called mkdirp. Yes, there is a completely separate node module for creating directories recursively as a standalone module. It's insane, and it's very hard to keep on top of, because in Node.js you can only specify your first level of dependencies, and then everything else beyond that is uncontrolled. For those of you who've used Ruby, which I've used extensively, you have two files. You have a gem file where you say, these are the 10 modules that I want. And then a gemfile.lock, which says, okay, when you installed this, here's the 200 other packages that were included, and these are the exact versions that you had at that time. So in the future, you'll be able to just install using the lock file, and your two systems will be the same. This doesn't exist in Node.js or the Node Package Manager. Sorry, I hear some protest there. I'm happy to be corrected later on. But this means that when you try and install a bunch of packages and then come back 5 minutes later and try and install the same packages, you don't know whether it's going to be the same, you don't know whether it's going to work. I spent days going through this going, I'm sure it was working yesterday, why is it not working today? That's what I think of Node Package Manager. But of course, we use it because of the existing tools that are there. Tile Live is the main suite. This is more like a kind of API that can be used for dealing with all kinds of mapnik-related things. Because everybody likes writing modules, there are different modules for everything. There's modules for storing map tiles on disk. There's modules for storing map tiles from over the web. And the bottom two here are the ones we're interested in today, which is being able to create the vector tiles using Tile Live Bridge, to be able to turn the vector tiles into images using Tile Live Vector. But all of these individual packages come with no documentation and no real idea on how to fit them together. And unlike ModTile and RenderD, there aren't dozens of other people who have been trying to do the same thing as you are. So my exercise in doing all this was learning what all these different bricks are, how do you plug them together, and what blows up when you try plugging two things together that nobody else has ever tried plugging before, but you thought was going to work in the first place. And this is where the jungle aspect of it comes, because there is no guidebooks here. There's no existing things saying, if you use these two components, it'll work. You'll be able to make some vector tiles. And so this is what I want to do now, is say, here is how I plugged it together. I'd love to hear if people have better ideas. So that's what I made my Lightning platform, is to create map images to be used from vector tiles. When I started the project, I had a few goals. These were mainly driven by my experiences with ModTile and what I wanted to do differently in the future. I wanted to have all the map tiles available all the time. So it doesn't matter if the server's busy, it doesn't matter if there's no, if you've just created the map style, it should be able to deliver map tiles instantaneously at any point. I wanted to be able to run multiple map styles, very similar ones, say like the transport map, but without the bus routes showing, things like that, with as low an overhead as possible. I wanted to try making it to see if I could render all the map tiles on the fly, even at the mid-zoom levels, which typically take 5 or 6 seconds. Can that be done in milliseconds instead? And the final point, continuous updates from OpenStreetMap. A lot of the tile live documentation assumes that you're doing things in bulk processes, so you might want to create all the map tiles, but then how do you deal with a diff update? What triggers what system to change? And unfortunately, I had a few constraints, one of which was I wanted to avoid using Node.js as much as possible because it drives me nuts. I wanted to write software that would run on my own Ubuntu servers, not using AWS, not using Azure, not using whatever Google's version is, because we're moving around hundreds of millions of map tiles, and when you start paying, even if it's 25 thousandths of a cent per map tile, you can press the wrong button and spend $2,000, and I'd rather not do that. And of course, it's just me, so I wanted to do the minimum viable product because I don't have vast amounts of time or money to spend on making overcomplicated systems. And after a lot of experimentation, I came down to a system which works based on 3 major components, vTiler, Hailstorm, and Weatherman, which I'll work through now and explain what they are. The first one is vTiler. It's a Node.js web app based on the tile live bridge module. So it takes the data and creates vector tiles, stores them onto disk. It can also serve those vector tiles out over the network, which is a great way of transferring them to other machines. And it just has a few simple commands. There's a command to generate a particular vector tile. There's a command to generate a world's worth of vector tile. And there's a command to take one from disk. And that's all it does. That's just vTiler. It just sits there all day long, creating vector tiles and then serving them out on request over the network. Hailstorm is the front-end machines. These are the ones based on tile live vector that take the vector tiles and create map images from them. It can fetch map tiles from across the network from vTiler. It stores them on disk. And then on demand, it will create map images from them. In both cases, I'm storing them raw on disk. I would love to use the MB tiles disk store instead, but it turns out that there's a few bugs with it, and it's slightly unstable if you're trying to write thousands of tiles in parallel into a SQLite database. So I went back to just storing them on disk in plain folders. The final stage is Weatherman. He's like the guy in charge of what's going on around here. He's taking the expiry list from OSM to PGSQL of what tiles have changed, telling vTiler that it needs to regenerate those tiles, writing out state files to say these ones have been updated, and then another copy of Weatherman runs on the Hailstorm servers, reading those state files and telling Hailstorm to fetch new vector tiles when it needs to. The state files are just the same as the OpenStreetMap state files. Again, kind of limited resources. I didn't want to invent my whole new way of saying what things have expired. So it's just the same system, same numbering system and all that kind of stuff. So I built all that, and I had no idea when I was doing it whether it would work, because this was all new and I had nobody else to check with. And so the big question is, did it work? And the answer is yes. Yes, it did. As we saw at the start, a month ago, I made it live. All of the transport layer images that you've seen in the last month have all come from vector tiles, rendered on the fly with no caching, continual updates from OpenStreetMap. All the things that I was hoping for at the start turned out to work. The rendering time is of great interest. How quickly can these vector tiles be turned into map images? You can see from the graph that the vast majority of them take less than 150 to 200 milliseconds in order to convert into a map image, which is great. It means that they can just be done on the fly when people want them. There's a few outliers that need to be taken care of. Of course, the rendering time is only part of it. They need to be fetched from disk, but this is even faster. So the combined fetching and rendering times, again, are still less than a quarter of a second. Covers the vast majority of the tiles. Because we're generating them on the fly, we can use different style sheets. Here's the same vector data, but just with a dark theme on it. It allows us to break away from the idea of worrying about what images we've already created. We can create retina tiles just because, you know, we just pass a scale factor into Mapnik and we get retina tiles. We can do retina tiles with any of our styles. We can have low bandwidth tiles. This is JPEG tiles with a 70% compression on it. It looks all right. There's some artifacts that you can see around the text here where you get JPEG compression things. But for low bandwidth scenarios, that's great. And again, there's no additional resources required to generate these. And so I'm very happy. But of course, looking to the future, what things do I want to do next? There's dealing with a few outliers that are slow to render. There's changing the way the files are stored on disk. There's embedding raster images into vector tiles, which takes a little bit to get your head around why you would want to do that, but it's the route to get really high-quality hill shading. So this is hill shading around west of London, or elevation coloring around the west of London. The tech for this was only created 14 days ago today, so it's very rough and ready, and it'll be a while before it's in production. Onboard rendering, you can pass the vector tiles onto devices like this iPad and have them just drawn live for you with rotating labels and smooth panning and zooming. This is fantastic. This is a piece of software called Maply by Steve Gifford, who might be in the room, but if not, he's hiding at the back up there. He's got a desk in the other room. I encourage you to go and have a look. These are the same vector tiles that I use on the main map layers, same Mapnik style sheets, just different tech. Constantine is about to come up and tell us what Mapbox are doing with rendering vector tiles. Because I'm using the same software, it's 100% compatible with whatever he's going to be talking about. And I want to talk to all you guys. If you guys have got ideas in your head about how you could improve transport map layers, how you can do customized things, how styles that you want to see done, come and talk to me. This is now much, much easier for me to help you with. If you want to make your own maps with your own data layers, come talk to me. I've got the infrastructure to start serving custom vector tiles for custom purposes. Thanks very much. Whilst we fix the microphone, does anybody have any questions?
If you have any questions, how does it work? It does. Okay.
Andy, thank you for your talk. I'm going to ask the obvious question, which nobody seems brave enough to ask. When will we see this tech on OpenStreetMap.org? Well, yeah, for the main style.
Yeah, so I think that was the sub-question, when is it going to be available for the main style? I don't know, to be honest. The main style is just one style. So at the moment, the purposes that we're running that map style for don't sit somewhere between mod tile and the vector setup. But obviously, we can open it up. I think there needs to be more than just me who knows how all these bits plug together before we can have a proper debate as to what the right architecture is. The setup that I've got for vector tiles can serve more tiles, but needs 3 servers to begin with, like one vTiler and 2 hailstorm machines. So that ups our cost within the foundation. But I think, to be honest, we should take a step back and say this is quite new. We don't have that many contributors to the map style for OpenStreetMap. Trying to get people to install TileMill 1 is hard enough. I'm certainly not ready yet to say you can only play this game if you're doing TileMill 2 and all that kind of stuff. So I think it will be another few months. There's no supported releases of TileMill 2, for example. I wouldn't ever say OpenStreetMap main style has to run on unreleased software.
Yeah. I should have probably clarified that actually one of the main applications that I have in mind are multilingual maps, which is a problem which I have to suffer on when I get governments complaining and stuff like that.
Great presentation, thank you. I had a question about why, if this is such a, I know you represent it as simply an alternative, but it's something that's better than sliced bread. Why did rendering happen with raster tiles first and not like in this mode initially?
Well, yeah, that's a good question. I would say it's because the tiles that we've used until now match what Google was doing back in 2006 when they first started bringing out Slippy maps. And what they were doing was optimizing WMS servers. So WMS servers were taking data, making map images, but in an uncacheable, unscalable fashion. So they invented the map tiles, which were cacheable and scalable, and then everybody else has been following suit. Within the OpenStreetMap community, there's not that many people who have run into the limitations of mod tile when it comes to either multiple styles or multiple servers. And Mapbox were one of the groups who ran into these kind of things. And so they needed this, and that's why they invented it. But now they've invented it, we should all use it because it's awesome. Does that answer your question? Great. I would also say the vector tiles aren't a new idea. Like, people have been doing various vector tiles for a long time. These are the first time where it's worked at this kind of, hundreds of milliseconds or less to draw the map images, using existing software that we're familiar with, having cartography that matches the cartography we expect to see, and all that kind of stuff. So it's more coming together of lots of ideas, and this is the iteration that, to me, works.
We have time for one more.
Yes, and I will ask one. You. So, how many zoom levels do your vector tiles have? Is there exactly for every rendered zoom level one vector tile, or how it works?
So the vector tiles that I make go from zoom level 0 to zoom level 14. Those are the vector tiles. The map images that can be created are good up to about zoom level 22. And then you start to notice on 22 and 23, you start to notice the simplification that was done back at zoom level 14 to make everything fit in that one tile. I think that there's a reasonably hard limit around zoom level 23 when the number of pixels in the world overflows 32-bit integers. So we're not likely to see zoom level 24 anytime soon. But at the moment, if you want the transport map at zoom level 21, it will do it for you.
Thanks,
Okay.
Andy.
I think that's it. Thanks very much for your attention.